We were about to go over the first example last time when things got ugly. So we got kicked off. My Wi-Fi was bad. So hopefully this time we're not going to have any problem. Okay. So everyone can see the board. Who can remind me what was the example that we're going over quickly? There goes Andres, right? Okay, who can tell me? Can somebody tell me what's the title for the example? Tiger Wood. Okay. All right. So example 1.
Oh, sorry I'm late. I was joining the 1-for-1 system parties.
Okay, welcome. We were on Tiger Wood. Tiger Woods, right? Golf. Okay. Make sure I get a marker that is working. Okay, so we say Tiger Woods was playing golf, right? And we say the mass, who remember, what was the mass of the golf ball? Anyone? 0.04 kilogram. Thank you. 0.04 kilogram. We say he swing. He kicked that ball with a high speed, high velocity. Who remember what was the velocity? 90 meters per second. Yes, because that's Tiger. He like to send the ball far away. Okay, so we say the initial velocity is 0 and the final velocity is 90 because he started from rest and then boof, right? So this is the final velocity. The initial velocity that never give it. So automatically we assume is 0. Okay, so initial velocity is 0 meter per second. Okay, and the question was to find, right? See, what impulse, right? What impulse does he impart? Does he impart? Right? To the ball. That was the question. Okay. So they gave us the mass. He swung it and sent it with a velocity. So it took off. Boom. Right? So they want us to find the impulse, right? Which is basically like the momentum. So we say if the given is the mass and the velocity, right? Then we know our momentum formula is the mass times, the impulse, J, was F times delta T, which was also the mass times delta V. Okay, that's what we say. Okay. The impulse is F times delta T, which is also the mass times delta V. Okay. We don't know the force, we don't know the time, but we know this. Right? Because this is the same as that. Okay. So the mass is 0.04 kilograms times delta V. We remember delta V is V final minus V initial. So 90 minus 0, right? 90 meters per second minus 0 per second. 0 meter per second, sorry. 90 meters per second minus 0 meter per second. Okay? So we have 0.04 times 90. Okay? So help me out. Use your calculator. Right. So we could see what answer we get. See if we all get the answer and type in your answer. Roxana got an answer for us. Okay, the unit is kind of wrong. Okay, the unit is kind of wrong, guys. What's the unit for momentum? Kilogram. You guys forgot, eh? Just look at the unit for each one. The mass is in kilogram. Thank you, Sophia. Thank you. Kilogram meter per second. So this one is in kilogram, this one is meter per second. So kilogram meter per second. Okay? So your answer is 3.6 kilogram meter per second. Okay? Hopefully you guys can see it. Okay? So don't just put kilogram. If you put kilogram, that will be wrong because kilogram is just the mass. Okay? So kilogram meter per second. We good? It's blurry for me, Mr. David. Is it blurry for everybody? Okay, all right. So okay, I'm gonna wait a little bit for Douglas. Okay. Oh yeah, the Wi-Fi. We know.
All right, Mr. David, I gotta get going.
Be good, Manny. It's nice to see you. Okay, I'll see you on Wednesday.
All right, bye.
Bye. Okay, Douglas, when you're ready, let me know so I can erase. And we'll go over another example. Took a screenshot when I was. Okay, all right. Rosanna, can I erase? Everyone? Liana, Jennifer? Jennifer, I'm good to go. Can I erase? Okay, all right. Thank you. Example number 2. So the first one was golf with Tiger Woods. Second one, we're gonna do hockey. Right? I'll use a different sport. Okay, hockey. So we're gonna have a hockey pod. Right? So you guys all know. Right? It's gonna be ice hockey. Okay. So let's say in a hockey game, right? Let's say you know the mass of the hockey pod, about maybe 0.12 kilograms. Okay? It's heavier usually than the golf ball. Okay, it's much heavier. It's some type of plastic. Right? It's a little heavier. Right? Let's say the mass is 0.12 kilogram. Okay, and let's say the player kick it with the hockey stick. Right? Use the hockey stick to kick the ball. Right? You gotta remember, the hockey is being played on the field, on the ice, right? Or if it's the field hockey, that'll be. But this one is ice. Okay. So it's not like golf when you want to send the ball far away. You want to send the ball, but you want to make sure it remains on the field. Okay? So it's not going to be like Tiger Woods sending that ball far away with 90 meters per second. No. This one will be much slower, much smaller velocity. Okay? So let's say when the athlete kick the ball stay in contact with the stick, right? For some time, let's say 0. let's say 0.05 seconds. Okay? The stick stay in contact with the ball for like 0.05 seconds before it took off. Okay? And let's say it took off with the speed, right, with the velocity of, want to make it lower, right? We don't want 90 meters. Let's say 20 meters per second. Okay? Much smaller. It's like 4 times, more than 4 times smaller. Okay? Or less than 4 times smaller than the golf. Okay? The golf was 90 meters per second. This one 20, so it's like much smaller. Okay? What question can they ask us? Okay? They can ask us the force exerted by the player on the ball. Okay? See? What force does the athlete exert on the hockey puck? Okay? Hockey puck. P-U-C-K. Okay? With what force did he hit the ball? Okay? Right. So if you ever play hockey, field hockey or ice hockey, you kind of have an idea. Okay? All right. So what do we know? We know this, guys. We know that the impulse is the force times delta T. Okay, that's what we say. But we also know that is equal to the mass times delta V. Okay? They're asking us to find the force. We don't know the force. Okay? So we're going to plug in everything we know. Right? We know 3 things. We know the mass is 0.12. So let's plug that in. Let's substitute the mass, 0.12 kilograms. Okay? Then we know the velocity, right? It's 20 minus 0, okay? The change in velocity, so this is like the final velocity, right? Final velocity is 20. He starts from 0 to 20, okay? So 20 minus 0 is 20, right? Meter per second. Right? So 20 meter per second minus 0 meter per second. Okay? We know the time. See, so I'm going to plug the time here, 0.05 second. 0.05 second. And the force we don't know. That's what we're looking for. So I'm going to put that in green, guys. Force. Okay. So force time 0.05 second equal 0.12 kilogram times 20 meter per second. Can we solve for the force? Yes. Divide both sides by 0.05 second. Okay. Second. Okay. So I'll wait for you to write this down and then slowly take your calculator and see what we get. Okay. .12 times 20 divided by 0.05. Okay. Share your answer in the chat after you finish. Good job, Sophia. You see how she's wrote Newton? Because we're looking for force. Thank you, Dayanara. Good job, Stephanie. Thank you, Jacob. Well done. I'm proud of you, Jacob. Thank you, thank you, thank you. Okay, make sure you write it down. Okay, so 48 Newton. Jennifer, we good? 48 Newton. Okay. All right. Good job, guys. You see, it's really simple. Okay. Physics is all around you. People say physics is too hard. No, it's just challenging. Okay. Who knew that you were doing physics when you're playing golf or hockey or basketball? That's all you're doing. Who knew that you're doing physics when you go up and down the stairs? Right? Who knew that physics is involved in collision? It's all physics. Okay, so it's all around us. Okay. Jennifer, we good? Can I erase? All right. Okay, I'm going to give one more example, guys. Okay, let's do one more example. Okay, and then I'll let you go. Okay, time is almost over. Example 3. Okay, example 3. Okay, so we did golf, we did hockey. Now let's use tennis ball. Okay, tennis. All sports stuff. Okay, easy stuff for us to remember. Tennis. Let's say you kick a tennis ball. You send a tennis ball with 10 meters per second. Okay, you send the ball. Okay, you send the tennis ball with 10 meters per second. So I'm going to say V final 10 meters per second. Kick the ball. All right. Let's say that's Venus Williams. Okay? I'm going to just use somebody we know. Venus Williams. All right. All right. Venus Williams smacked the tennis ball, send it with its velocity of 10 meters per second. Okay. The ball leaves her racket. Right? The ball leaves her racket with a velocity. No. Okay, let's change it. We're going to change it a little bit. A tennis ball is traveling. There we go. Is traveling at 10 meters per second when Venus return it with a speed. Okay, I'm changing it a little bit. With a speed of 36 meters per second in the opposite direction. Okay, in returning in the opposite direction. It makes more sense in the opposite direction. Now this is more interesting. Okay. All right. So the ball was coming toward her, and she smacked it, sent it back in the opposite direction. Okay. What is the change in momentum of the ball? What is the change in momentum of the ball? Okay. So let's answer that and we'll finish next time. Okay. We're going to answer just this part and then we'll finish later. Okay. All right. So let's say Venus. What's her sister's name? Serena, right? Serena? Right? Okay. You guys know Venus and Serena, right, guys? The Williams sisters. All right. So let's say that, okay, good. So let's say, all right, Jacob, let's say Serena and Venus are playing, and Serena sent the ball at 10 meters per second, right, to Venus, and Venus just smack it at 36 meters per second. So he changed direction, okay, all right. So 10 meters per second, 36 meters per second. Did I give the mass? You gotta give the mass. Let's say the mass is we said the golf ball was 0.04. Tennis is a little heavier, right? So let's say 0.06 or 0.0, yeah, about 0.06, okay? Let's say the mass is 0.06 kilogram. Okay, we gotta make sure it makes sense, right? The tennis ball is a little heavier than the golf ball, but it's not as heavy as the hockey. Okay, so we gotta try to make sense. Okay. All right. So we know the mass, we know the velocity of one, we know the other velocity. Okay. So let's see. What is the change in momentum? Change in momentum, delta P, change in momentum, equal to the mass times the change in velocity. That's what we said before. Okay. We good? So how do we do this one? It's a little tricky. Okay? It's a little tricky. We're almost done. But we know if Serena is sending the ball here, right? Serena send the ball. Okay, so Serena sending the ball this way. Then Venus kick the ball in the opposite direction. This is Venus. Okay, so draw these two arrows for me. Okay, it's gonna help you understand better. Right? So Serena send the ball going this way. Venus kick it in the opposite direction. Okay, so we could say the final velocity, right? That's right. That's the velocity of Venus minus the initial velocity, the velocity of Serena. Okay, so the mass, we say 0.06 kilograms times the final velocity. The final velocity will be the 36 meters per second minus the initial velocity. Who can tell me what's the initial velocity here? Let's see if we think incorrectly. What's the initial velocity here? You could write it in the chat. 10 meters per second. That's what Alex think. Anyone else? Samantha think it's 10 meters. Jacob think it's 10 meters. Andres, Senor, Garcia. Anna think it's 10. Celeste, are you there? What do you think the initial velocity is? I just want to see how you guys are thinking. Ah, Sophia. Sophia say in the opposite direction. Opposite direction means the sign changes. Okay? The sign changes. So, Sophia, yes. So that'll be minus negative 10 meters per second. Thank you, Sophia. Okay? So guys, it's not just 10. Yeah, yes, Alex, because it changes direction. Right? Okay? I'm telling you, physics, man, is weird. Right? So you guys know it changes direction, so you gotta put double negative. Okay, so that become plus 10. So 36 plus 10 is 46. 46 times 0.06, Liana. Okay, so it's 46 times 0.06. 0.06. So Liana, your answer was correct. How do you get it so fast? Oh, no. It's a little off. You said 216 there. No, it's not 216. Yes, Liana, because when you're playing, the ball is going left to right. So if it goes left, right, gotta take into account the direction. Okay. So what do you guys get? So 1 point? No, Roxana. I don't think it's 1 point. Roxana, can you double check for me? Por favor. Somebody give me the unit. 2.76, what? What's the unit for momentum? Kilogram, meter per second. Thank you, Dianara. Okay. 2.76. Good job, guys. 2.76 kilogram meter per second. Okay. Because my internet, my Wi-Fi was having trouble, we are behind. So because of that, Wednesday we're going to continue, and instead of having our test on Wednesday, we'll have it on Friday. Okay. I'm going to have tutoring session today. I'll have tutoring session tomorrow, okay, and so on. Okay. I'm going to have special tutoring session today. Okay. I'm going to check with the science department to see if we have meeting. If we don't have meeting, then I will have tutoring right after this. Okay. Thank you, everyone. I apologize for the Wi-Fi technology. It's kind of getting me into trouble. Jacob, thank you so much for taking note, okay? Always write the date, okay? Write the date. Today is the 8th, okay? So every time there's problem, you say, oh, that date I was in class. Here's the date. Okay, Jacob? Write the date on top of the page, okay? All right, my friend. Be good, everyone. Be safe. Don't forget to wear your mask. Okay, and I'm going to go to tutoring right now if we don't have a meeting. Okay, I'm going to check with my department and then tutoring. It's going to be the same link. Okay, the same tutoring link. Mr. Siriki, see you later at the meeting. Bye-bye.
Absolutely.
Okay. Bye, guys. Hi, Rosanna. You too. Be good. I'm going to try to see if we can have a tutoring, okay?
See you, Mr. David.
Bye-bye, Andres. Bye. Mass 8, period 4. Meeting. Let's save this. There we go. Go back and fix the attendance.